Hold on a second. I'm still working with 8th grade a bit here. We are going to attempt to try what we did yesterday. I don't know why YouTube flagged it as inappropriate content, but that's what happened. I did not appeal because I didn't care as much. We're just going to try again today. Um, so whatever popped up today, we're kind of a day behind, but this should be pretty easy to catch up to today. So when we finish this, I'll start the next one and go from there. But if you do follow along with the PowerPoint from writing equations, it's going to be a little easier just so you have the words in front of you. I'm going to try to copy and paste everything in, and we'll see if this live stream lasts. If not, we'll find some other way to do it tomorrow. But writing equations is not hard. It takes practice though, and it takes some reasoning skills, and it takes some good reading to know what's going on. Do we need to do the work that is for today? No, hold off on that. Unless I teach you about it, then you'll do it. But it's looking like everything's getting pushed back a day. Google Classroom is automated right now for me, so it's going to just keep unlocking the next day after the next day after the next day. And I have to go in there and fix it all, which is going to be a pain. So I'm just going to let it unlock things, and then we'll just be a day behind. If you want to work on it and figure it out, it's really not difficult. It's everything you've been doing. There's just like one more step, which you already know the theory behind why it's going to work, if you want to look at it closely. But I'm going to look at writing equations today, which is what we kind of did some of yesterday. And then if we have time, I'm going to go into what is actually for today as opposed to what was yesterday. So yeah, we're going to be doing yesterday's work. I don't know if I put a docs for yesterday or not. I don't have everything open that I want to open. Yeah, there's a docs for it. You are required to do page 364, 1 through 11, if you haven't done that yet. A lot of you might have attempted that yesterday, but as of right now, I didn't really give you a good lesson on it, so I'm going to do that first. So first we're going to be looking at this problem, which we started yesterday. I'm not exactly sure when everything got timed out, but we're looking at Floyd here, who is an aspiring musician, and he's got some album sales, and he's got stipends for base rates of money. But basically you're going to be reading problems like this, and you're going to be picking out how to write this into an equation. So the first thing you probably want to look for is your unknown, and it's pretty easy if you read it and then kind of ask your question like, okay, what information is missing? So what's missing here? And that's his album sales. So we don't know how many albums he sold. So we're going to call that our variable, which I'm just going to call A. And in that case, you know his total is 640. So everything has to add up to 640 because that's what total means. And you have a base rate of 200, which he's just getting flat out for the month. and then he's getting $12 for each album sale he's sold. So that's plus 12 times A, because that's going to tell us how many albums he sold. So however many albums he sold times $12 is going to be how much money he makes from his album sales. And this here is your equation for it. And I believe we did do that one yesterday. But that's all I'm looking for today is writing the equation. You don't have to solve that unless you want to. It does make good practice, but I mean, solving it, you got positive 200, so subtract 200, subtract 200. You get 12a equals 440. Divide by 12, divide by 12. A equals, I have no clue. 440, 4 divided by 12 gives you 37. So he sold 37 albums. But again, it's asking for today. We're looking for the equation. Yeah, you do work today. You do work every day. Yesterday was just kind of a fluky thing. But so this is what I want for today. Take a look at the other stuff because I plan on getting to it during the live stream. Because writing equations really just is reading. It's, do you have good reading skills and can you translate those into symbols? So let's look at another one. And again, I am walking through the PowerPoint here, so if you want to follow along with the PowerPoint, that's why I put it there. It's advised for you. Some problems, the reading's pretty easy. This one here tells you exactly what you do. You just need to put it into kind of like your number sentence. I will help with the questions on the book after I'm done with the actual lesson. I advise you to listen to the lesson because then I will answer most of your questions probably. And you'll get some examples on how to do things. So here it's saying when 6 is added to 4 times a number, so there's a number, that's your variable. I'm going to call that n. So whatever number it is, I'm going to call it n. When 6 is added to 4 times a number, the result is 50. Find that number. So again, it's very intuitive on writing the equations. It comes right out of it. When 6 is added, so I'm doing 6 plus 4 times a number, and again, a number is n, so 4 times n, and my result has to be 50, so that has to equal 50. So my equation comes right out of it. 6 times 4n equals 50, and then you solve for n if you needed to. There are some strange ways things are worded, so again, read very carefully. So looking at the next problem, and again, I'm not asking you to solve these today, I'm just asking you to write the equations. So looking at our next problem from the PowerPoint, just read carefully and it's easy. Right? The sum of a number and 9 is multiplied by that. So this one here, if you read carefully, it's the sum of a number. There's your unknown, a number. I'm going to call that n again. The sum of a number and 9 is multiplied by -2. In that case, it's asking you to do the number and 9, the sum, and sum is addition. So the sum of a number and 9 is right here. That number plus 9 is the sum of a number and 9. And then we're multiplying that whole thing by -2. So here you do need to add parentheses and have -2 there. And then the answer is going to be your -8 in this case. So again, pay attention on how it's worded, but I mean it's just being able to interpret the wording of questions and kind of plug it into what they have there. Next couple are a bit more challenging because, you know, more we get into this, the more wordy these questions are going to be, the more complex these equations are going to get. But again, just take your time, read carefully, read things more than once, and you'll end up being just fine. This one says, on an algebra test, the highest grade was 42 points, higher than the lowest grade. So if I had variables for my highest and lowest grades, I could come over here and be like, well, the highest grade, which we'll call H, and the lowest grade we'll call L for now. Right? The highest grade was 42 points higher than the lowest grade. So in order to get the highest grade, you need to do 42 points more than the lowest grade. I'm going to use a cursive L because that looks like a 1. Right? So the highest grade is 42 points more than the lowest grade. So you take your lowest grade and you add your 42 to it to get your highest grade. The sum of the two grades was 138th. So here, whatever my highest grade is, which is right here, because that equals the highest grade. So the highest grade plus the lowest grade equals 138th. So in this case, I can actually substitute in, instead of writing H anywhere, I can use in terms of L here. So here, the highest grade is equal to 42 plus L, so instead of writing H here, I could write 42 plus L, because they're the same thing. I can then take this and combine my like terms, and I can get 42 plus 2L equals 138th. And this here would be my equation for this. Note how you can do a simple substitution to get out one of your unknowns if you have multiple unknowns. And together these things are actually called a system of equations, which later on you will get into solving a little better and you'll get more practice with writing these. But it does get a little complicated, but it's just reading things out. So on an algebra test, the highest grade was 42 points higher than the lowest grade. So just looking at that part, I can get this. Then the sum of the two grades being this. So whatever this is plus my lowest grade is going to equal 138. And then I just combine the like terms. Not difficult, just takes some reading. And again, you might have to read things multiple times. The last one I want to quickly go over is also in the PowerPoint. Then I'll start answering questions from the book if you have them. And this one here is going to be a bit more wordy as we go. So here we have, at the end of the day, a pharmacist counted and found that she has 3/4 as many prescriptions for antibiotics as she did tranquilizers. Okay, so let's just look at that first. She has 3/4 as many antibiotics. I don't know how many antibiotics she has, so I'm going to call that A. And I don't know how many tranquilizers she has, so I'm going to call that T. So here she has 3/4 as many prescriptions for antibiotics. Or I'm sorry, 4/3 as many prescriptions of antibiotics as she did tranquilizers. So what we're going to do is we're going to take that 4/3 and we're going to multiply it by A. So 4/3 as many as she did tranquilizers, and that's going to equal the number of tranquilizers I have. Right? 4/3 times antibiotics, 4/3 as many prescriptions of antibiotics as she did tranquilizers. So 4/3 times however many antibiotics I have is going to give me the number of tranquilizers I have. She has 84 prescriptions for the two types of drugs. So here I have 84 prescriptions, which is equal to however many antibiotics I have, plus however many prescriptions of tranquilizers I have. And then it's asking how many prescriptions did she have for tranquilizers. Well, I know that tranquilizers equals 4/3 a, so you could substitute that all in, or you could sit there and solve this, which is what we're going to have to do for a, and substitute it in here. So 4/3 as many prescriptions for antibiotics as she did for tranquilizers. So here you want to solve this for a, which there's going to be a lesson on how to do that as well coming up this week. But just a little sneak peek, we're going to take this. I'm going to move it over here so I can write underneath it. And we're going to solve for a. And you're going to do the same thing you do with your algebra, only here we have variables you have to deal with. And we want a to b by itself, so we're going to divide this by 4/3, and you're going to divide this by 4/3. And that is going to cancel out this, and you're going to leave you're with a over here. Over here you can't really do t divided by 4/3, but you can rewrite that better as multiplying by the inverse, right? So in this case, you're going to do 3/4 times t. So it multiplies by the inverse. Now you have what a equals, and then you can come over here and you can do 3/4 t plus t. And again, you can add those together. So 84 equals 1 3/4 t, because 3/4 t plus t is 1 3/4 t. And this here would be your equation. You're not going to get something this complicated right now. You're probably going to start with smaller things. So I will remind you that in the classroom you have your assignments, which is page 364, 1 through 11. And if you have questions on that, I will start. Christian was talking about number 1. I'm not going to sit here and rewrite that problem because it's a word problem. So if you are struggling with number 1, please reference number 1 out of your book. Let's see where I can find it here. Number 1 says the sale price of a sweater. I'm going to take some notes over here as I read. I know sale price of a sweater is $48. The price is 20% less than the original, so $48 is 20% less than original. And I want to know what the original price is. Original price is unknown. So this is the information it gives you. And you're going to set up an equation to solve this. You don't actually have to solve this. We're going to just write the equation for it. Anthony, we are doing this. This is what's due today. Yesterday kind of got screwed up, and the automation in the classroom is going to unlock things all week until I figure out how to change that simply. So you're just going to have to be patient. I will try to get to that as the next assignment when I'm done here today, just to give you some idea on what's going on. But the 3/323 on 369 really is not hard. Page 369, yeah, you're eventually going to have to do it. It's going to be due Wednesday, though. Today's Tuesday. It's going to be due Thursday. It's getting pushed back a day. So originally got unlocked today, so I originally wanted it due tomorrow, but that's not going to happen, so make it due Thursday. Yeah, you don't know how to do 369. That's why I'm spending either later today or I'm going to spend tomorrow doing it, depending on how many questions we have on 364. So that's going to get pushed back too. Yeah, Luke, once I'm done with number 1 here, I'll jump to 8B. Yeah, I'm sorry for the confusion. It's just we got pushed back because YouTube didn't like my stream yesterday for some reason. Even though I'm doing the exact same thing today. So here we're writing the equation. We want to know the original price, so we're going to call that a variable. I'm going to call that x because O's look like zeros. And in that case, I don't get mixed up. So my unknown is going to be my original price. So my sales price is $48, and that is 20% less than the original price. So what I'm going to do is I'm going to take my original price, I'm going to subtract 20% from it, and that's going to equal my sales price. And that there is your equation. Now just keep in mind when you do solve things like that, you don't use percents, you use the decimal version of it. So a better way of writing that would be x minus the decimal version of this, which again, move this twice, 0.2 equals, oh, I'm sorry, this is a percent. You got to find percent of it. So x minus 0.2 times x equals 48, because that is a percent. So this is 20% of x, so to speak. But yeah, you have x, and then you're going to subtract 20% from it, and you get the 48. Well, what is 20% of x? That's what you need to figure out. So this here is your equation to figure out 20% of x. And therefore you get the 48. To solve this, you're going to have to combine your like terms here. So when you do that, this is a 1 in front. So you actually want to find out what let's look at this first. We'll look at this one first. This one here, this is 100% in front of here, and this is 20% of x. So 100% of x minus 20% of x gives you that 80% of x equals, and that's a percent, equals the 48. However, we don't deal with percents like that. We change things to decimals. So that's really not a good answer for that question. Here you're going to change the 20% to a decimal and the 100% to a decimal, which is 1. And then 1 minus 0.2 is going to give you 0.8 times x equals 48. And that makes more sense because, is this, no, it's the sales price. Hold on, I'm confusing myself. I'm going to start over and see what comes of it. So our sales price is $48, and I want to know our original price. We still want the original price, which is x, minus 20% of x, so I'll write it like that, has to equal the 48. That's still true, right? Sales price is that you have your original price, take away your original price plus, or time 20% times the original price equals 48. That should be right. So in this case, you're going to get 20% of the original price is your original price. Yeah, your original price minus, I was doing that right, minus 20% of x. So yeah, I guess you're just taking the 0.2 out of it, which is still going to be 1 minus 0.2. That's still going to be 0.8x equals 48. I'm just going to solve this because my brain's jumping over here. Let's see if my number makes sense. It does not. So I'm doing something wrong here. I'm going to reference the book real quick. I mean, you could always set up the equation the other way too. Using the proportions from last chapter. 48 is 20% less than the original price. So you have 20% out of 100 equals x over 48. I mean, that will work. That's how I normally do it. In that case, you should be getting 60 as your original price. I'm still getting 240 because I want this to be 80. Yeah, that's where I'm getting confused. That needs to be 80 because 20% less than the original price. So 100% of the original price minus 20% of the original price equals 48. So this is a total of 80% of the original price equals 48. And again, you can't use 80%, you got to use a decimal. And that's giving you your 60. So yeah, we kind of went the rough way out of doing it. Technically, this here is an equation too. So if you want to use that as your answer, that's fine too. But that's kind of stuff we did last time. Luke asked for 8b, which I have a feeling I'm probably going to have to do all of 8. It is saying it takes 8 painters 6 hours to paint walls of a gymnasium. So 8 painters takes 6 hours. How many hours does this job require? How many person hours this requires? So if each painter is painting for 6 hours, we have 8 times 6. So 8a is just going to be 8 times 6. Gives you the 48 hours. 8b is asking how many hours will 12 painters take to paint the gymnasium. So 12 painters to paint, is that right? 12 painters to paint. So if it takes 8 of them 6 hours to paint, it's going to then take, you can scale this. You don't understand 5 when I get a chance. So you can scale this. Let me think of how we do this. 8 painters, 6 hours. So we have 48 hours. You have a total of 48 hours to paint it. It's still going to require the same amount of time. However, here we have 12 painters instead of 6. $48 divided by 12 gives you 4 hours. You get that? Yeah, so instead of having 8 painters, so your formula is really painters times hours equals 48, right? So if you have 12 painters, however many hours it takes to get 48, it's still going to take 48 man hours each time. Number 5. Alright. Lamar's summer job is mowing lawns for a landscaper. His pay is $7.50 per hour pay. He also makes $11.25 per hour over the 40-hour mark. And it's saying he worked 40 hours last week plus some overtime equals 339.38. And it wants to know how many hours overtime he made. So to solve this, we need to substitute in some prices here. So he makes, let's solve his normal 40-hour rate. For the first 40 hours he works, he gets paid $7.50 per hour. So $7.50 times 40 is going to give you that much money, how he makes for the first 40 hours. This equals, makes for the first 40 hours. So in that case, you can solve that. We can get that number if we wanted. We'll get it at the end. For the next set, right, so here we have 750 times 40. That's going to be added to the number of hours he makes for working 11.25 per hour. So then 11.25 times however many overtime hours he has is going to equal 339.38. So this here is our equation, and we can solve that. First we'll do this part. So 7.5 times 40 gives us 7.5 times 40. He made $300 for just working your 40 hours, plus 11.25 an hour after, and it's adding all up to 338.38. So then subtract 300, subtract 300, 11.25 times h equals 39.38, divide by 11.25, divide by 11.25, hours equals 11.25. You're looking at, that's not right, 39.38 divided by 11.25. You're looking at about 3.5 hours. he worked overtime. So that's how much he worked overtime. I don't know. Did the question ask for how many he worked per week? No, it's only asking for how many he worked overtime, which is 3.5. If you wanted to know how many he worked per week, you would add that to the original 40 that he worked as well and get the 33.5. But that is number 5. Next up, Jason, number 10. Number 10. Physics. The weight of an object on Venus is about 9/10 of its weight on Earth. The weight of an object on Jupiter is 13/5 times the weight on Earth. So just getting the information pulled out, we have the weight of Venus is 9/10 Earth. I don't want to use E. I'm going to use X. And it also says the weight of an object on Jupiter. So Jupiter's is 13/5 the weight on Earth. And we want to know the Venus weight is 23 pounds. And I want to know Earth's. And that's for A. And for B, the Jupiter rate is, oh I know, the Venus rate is still the same, right? Same rock on Jupiter. Yeah, so the Venus weight is still 23 pounds. I want to know the Jupiter rate. So that's the question. So what you do is you just kind of solve for x on each of them. So here we have Venus rate is 23 pounds, so for Venus we have 23 equals 9/10 x. We divide this by 9/10, divide this by 9/10, which is multiplying by the reciprocal. So be aware of that. So this cancels, leaves you with x on this side. Over here we have 23 over 1 times 10 over 9. Let's see, can't pre-cancel that at all, so we got 23 times 10 divided by 9. You're getting 25.5 repetend on Earth. So this is the Earth's weight of it. That is Earth's weight for it. If you want to leave that as a fraction, that would be 25 over 5/9. It might have been easier to do the math with leaving it as a fraction. But that is the Earth's weight. So over here I know the Earth's weight is 25.5 repetend. And then I can take that Earth's weight and I can plug it in over here for part B. I'm just going to delete that, and we get part B is asking for Jupiter's. So here we're going to do Jupiter's is going to equal 13/5 times 25.5 repeating. And that's just simple math. Times 13 divided by 5. And you should be getting, again, you can imagine this being over 1, 13 times 25, and then divided by 5. Jupiter is going to be 66.4 repeating pounds. Or you could have done the 66 and 4/9 if you kept things as fractions. It's all the same. Luke wants number 11. Number 11 says, Jackson, Petra, and Tyrone went to the beach and collected seashells over the weekend. Jackson collected S seashells. So Jackson equals S shells. Petra and Tyrone collected 13 each. Oh, each collected 13 fewer than twice the number of Jacksons and twice Jacksons. And in the end, they had 94 shells. 94 shells. Okay, a lot of information floating around on that one. First thing to keep in mind, Petra and Tyrone are two different people, and they are each collecting fewer than 2 times Jackson. But you do know that Petra and Tyrone both collected the same amount, and you know that Jackson collected S. You also know that whatever one of these you want to use, let's just use Petra. Petra is going to collect whatever 2 times Jackson was minus 13. So 13 fewer than twice Jackson's. And that's going to be true for Tyrone as well. 2 times however many Jacksons did minus 13. And you need the total is going to be 94. But you know Jackson's is actually equal to S, so we can get rid of the J and use an S. And you know that whatever Petra, Tyrone, and Jackson got, it was 94 shells. So just kind of reasoning through what information you have. Here you're going to get, well, Petra's, which is 2 times S minus 13, plus Tyrone's, which is also 2 times S minus 13, plus Jackson's, which is just S. And then you can sit there and combine like terms. 2S plus 2S plus S, so that's 1, 2, 3, 4, 5 S's. And then we have minus 13. Minus 13 is minus 26. And together that equals 94. This is an S. Plus 26 here, plus 26 here. You get 5S equals 112. Divide this by 5. Divide this by 5. You get S equals, what is that, 24? 120 divided by 12 gives you 24. Yeah. 24. So you know Jackson equals 24. So S equals 24 shells. If you know how many Jackson got, then you know these two. You can just go back to one of these equations and plug it in. So plug it into this one here, so to speak, and you get Petra is going to be 2 times 24 minus 13. 2 times 24. 2 2 times 24 minus 13 gives you 2 times 24 minus 13 gives you 35. So in this case, P equals 35, and you know that P and T are the same. So overall, everything that we know from this, just to give myself more room, through all that math, you know that Petra and Tyrone's each got 35 shells. Tyrone got 35 shells, and you know Jackson got to 24 shells. Hopefully that helps you out there, Luke. Again, we are a day ahead on things being unlocked out of the classroom, so I will go over the other stuff tomorrow. It's not too difficult if you want to take a stab at it. But page 3, this is what's due by the end of the day. And I did pretty much half of those for you. So, any other questions, email me. But we've done this long enough. We've been on for going on an hour here. So if you have any other questions, shoot me an email. And I'm going to end it there.